Hello and welcome back, everyone, to Space Simulation Toolkit. It has been a long time. Why? I bought a house, I had a child, I moved across the country, and I'm working like 3 jobs, and other things are going on. But it's okay, Valor's still being worked on, everyone. Everything's okay. Yay! And we're back. There's gonna be more videos. I'm not leaving you again. I went to get milk twice, but I will not do it thrice. Because I got all the milk I need. And guess what? There's new simulations for this game that people have made. But most importantly, there's like a new major one called Star, which I'm really excited about because it's official, and official things are cool. So we're going to get a 3.2 million particle map, and we're going to see what is going on. Oh my god, it is legitimately a star. Wait a moment. Is this going to do what I think it's going to do? We are getting some sort of major collapse here in the center where all of the mass has kind of collapsed inwards, creating nuclear fusion, it would appear. Wow, they've added a lot since last time. And we've got an actual star, and now we have rings. No rings with gravity. They're forming asteroids. You've got to be kidding me. This is like exactly what I've been waiting for. And I only had to wait. Well, it didn't even feel like any time because I was watching my new daughter grow up. So this is a great way to come out of retirement. Look at this. There's so much material just being pulled into the star, but there's a lot of material that is stable, and not just stable, but it is grouping together into these beautiful bands. These bands of material. You'll remember almost every simulation game that we've played, especially Space Engine, not Space Engine, what's the one? You'll know which one I'm talking about if you remember. You get these beautiful bands that form, and it's kind of just one of those cool things in physics. And these are going to become tiny little protoplanets and eventually planets, but we're actually getting this sort of ring here. Like an asteroid belt is forming here, probably because this star is actually expelling a lot of material, which is hitting other material and forming kind of a barrier. So this is very unique to Space Simulation Toolkit. You don't see this happening very often, but it's very interesting. We have a lot of material just all over the place. I don't know, is this water? Is it blue because it's water, or is it just showing temperature? Oh, it is water. Oh, so we got like this white light, not white, water, which is actually gravitationally, you know, going in and touching all these other. Oh, that's cool. It kind of focuses on the particle. Wait, did he have a camera tracking? No way. Oh, he did. You can click and it'll track. Oh, that's so good. That's so good. Unfortunately, even my 4090 is struggling a little bit with this simulation. So what we're going to do is we're going to actually leave the game, because I'm going to tell you, if you play this game, if you're going to do a really large simulation, just turn it off and back on again afterwards. It works better, clears out your video memory, and then you're going to run into a lot less craziness in the future. But then you just start the game up again and start, and we're going to do a 1.6, and then just so that you guys can have a nice, creamy 60 FPS experience. Yeah, that's much better. It's insane that even 1.6 million particles with gravity and can be simulated on consumer hardware like this. This is absolutely insane, and I cannot wait for the 5090. Yeah, the developer is going to send me a 5090, right? Right? No, not really. We're not affiliated. Someone in the Steam comments accused me of being like paid off to give this game good reviews and videos. I'm not paid. Well, I'm paid by you. I'm held accountable to you, the viewer. But no, not sponsored. Just love the game. So, legitimately, my own opinion that this is the future of particle sandboxes. A little rough on the UX side, but that's okay. I have a feeling it's going to get better as time goes on. And one of the greatest things is having the Steam Workshop, which I've seen actually more and more things appear on. So that's exciting. All right, so we got these little planets which are forming. Huge fan of that. We're gonna follow this one and kind of watch what happens. They're definitely getting into bigger and bigger groups, but how many will remain, and will they all end up falling into the star at some point, or will they stay stable? This is the question. Is there an answer? Who knows? Who knows? Anything could happen at this point. You've got like your little planets up close to this star, like Mercury forming, which are all super hot. And then you've got all of these faraway ice planets, and then right in the middle you have the Goldilocks zone, where you're getting these planetoids which actually have liquid water. And so these ones are the ones where we could actually expect to see some life. And as time goes on, I'm hoping that a few will remain that I can actually plop some plants onto. It does appear that as the simulation goes on, it's getting a little bit harder to simulate, probably because I think in the background this is using the grid system for collision, so as things get more globulated, that's a word, right? Globulated, I think it messes with the optimization a little bit, but that's okay. It's fine because it's still playable. It's playable. Tiny bit of lag. But most people probably don't even need 1.6 million particles to have a good time. Oh, what is the star doing? Oh, it expanded. Now it's contracting again. I guess it's kind of like, so it's kind of going wee woo, kind of like a solar cycle there. Speaking of which, I saw some beautiful aurora outside of my house the other day. Just reminded me. Solar activity, you know, very cool stuff. And as you can see, these planetoids are actually the more dense material, like rock is slowly going towards the center, but occasionally, like we just saw, there's a collision between an asteroid, and here it's actually going to be two planetoids colliding. Ooh, that was rough. And this one, actually, the gravity, they didn't quite collide, but the gravitational force was enough to rip it apart. And look, these ones are actually colliding with it now. Oh yeah, these planetoids are starting to really combine, which is what we want to see. This is one of those simulations that at some point I'm just going to let run for hours and hours and see what happens. Of course, that's not for today. Right now I just want to see what can happen in a reasonable time span, you know. Oh, here we go. Two planetoids colliding yet again. Look at all the energy. The red hot energy that's let out from these collisions. Oh, and a third one's coming, and a fourth one even larger. Oh man, these are going to form a beautiful mega planet together, unless they get ripped apart. There's no knowing if it'll be strong enough, if the gravity will be able to hold it all together, or if they're just going to go find their own way again, but it looks like they're going to connect. It looks like this one is at least eating a lot of the material. It may not end up completely capturing this. What's interesting is we could actually get a double orbit going on here where we have the planet orbiting the star. We could get a smaller bit of material orbiting one of these planets, which would be a moon. And you know, moons are cool. But as you can see here, we definitely do have orbiting going on. We have an orbit going around an orbit, which means this is a pretty powerful simulation. I wonder how he managed to get the details on the simulation just right to make this possible, because this is beautiful. This is actually like, this is incredible. Remember the video where I was trying to do this on a much smaller scale and failing for like an hour? Well, it's just working. Just working. So there must have been a lot of trial and error that when, oh no, asteroid, oh, that was brutal. Absolutely brutal. Yoinked it right apart. Oh, wow. Someone's going on over here too. Oh boy, this planet has just been absolutely ripped to shreds. To shreds, you say. And some of these planets are just getting too close to the star and getting turned into asteroid belts. They're being just torn apart. But the planets that remain, there's only a couple now, and they're very large. There's a couple very large planets left, some smaller like asteroid sorts of things. Some material just got flung really far away. Like, nothing really big, but there's a lot of little bits out here. Oh, look at this. Yeah, that one did not end well. The collisions between the planets are getting more and more violent, and instead of really merging at this point, they're kind of just being ripped apart by them, so it's... I'm curious how many will remain at this rate. Like, look at this. This is going to be brutal. If they end up hitting. I think they are, though. I think they're going to hit. Oh, just a grazing shot. They did not collide. We got these, like, pill-shaped ones. They're just getting so large that the gravity, they can't really hold themselves together anymore. It's kind of a catch-22. The larger the planet, the more prone it is to being ripped apart. And this would actually be in, like, Universe Sandbox, if you remember the Roche limit. Yeah, pretty much. They're too close and too large, so parts are just being ripped away from that gravitational pull. Or was that when the planet spins too fast and then spins itself apart? I may actually have that one wrong. It's been a while. I'm tired. I'm dealing with a newborn who wakes me up at 2 a.m., so forgive me if I use that term wrong. Anyways, this is amazing. This is really good. Oh, this is going to be a huge one, especially considering this one's already, like, liquefied. It's lava. So much energy from these collisions, and bam! Not the biggest, like, it didn't really collide, but you can definitely see, well, all of the energy. The energy is almost more interesting than the matter, you know that the matter is all going to coalesce into one spot, but all of the energy from the planets as well is getting concentrated, and so the planets that remain are just so hot and unstable. There were a lot of really little stable planets before, but now it's just like, now everything is very angry. Now, oh, this one's gonna be big. Here we go. We're actually gonna get, oh man, they always end up missing. I always get so excited. And then, okay, this one's gonna hit. This is going to hit. Oh! That was so dramatic. The entire planet got vaporized. Oh, wow. It looks like there's enough gravity to kind of hold it together, though. Something's going to survive. Maybe? Maybe not, because things keep hitting it. Oh. Very dramatic indeed. This planet over here is actually being ripped all the way apart. Yeah, look at that. It's just getting torn. Another planet just collided and exploded, and now it also is becoming a part of this. It looks like the amount of entropy in this system is increasing rapidly. It's quite brutal. There aren't many stable planets left. A lot of the material is just ending up falling into the star. Oh man, will anything remain? Oh, over here, these two too. No! Oh man. Nothing is going to survive. It looks like these aren't actually going to collide though. Over here, that collision, it actually seems to be stabilizing a little bit afterwards. There's a lot of material that was thrown out though. Honestly, these planets are getting about as large as the star that they formed around, which is why the star and, well, the planets, everything is so large that when they collide, it's far more dramatic. Far more dramatic. And it's having a really hard time stabilizing. A really hard time. I wonder if I clean up some of the particles, if I can get this to speed up a little bit. I'm just going to take this, and I'm just going to do some cleanup of all the particles out here that we don't really care about. They're not really a part of the simulation anymore. Doing a little bit of cleanup to speed up the simulation. Alright, I'll see how that... Does that help at all? Not really. But I can try to clean up, like, over here, just where there is nothing going on. Because as more and more of the particles conglomerate in the same area, the simulation does start to chug a little bit. There we go. Okay. Alright, I'm happy with that. Let's get back. Let's get back. It looks like we're ending up here with 3 planets that are going to remain for who knows how long. There's something here, but I don't think it's going to survive. It's about to be ripped apart by the star. Oh, the star itself just got hit hard. And it's about to actually, it's like a coronal mass ejection here. It's throwing out a lot of material. Oh, geez. This is the most planet-looking one right here. It's just got so much energy. It's not cooling down. And oh, no! Oh, gets smacked again. Wow, there's all these little things. This one is actually orbiting the other way. Oh, that's interesting. We haven't seen anything orbiting counterclockwise yet. So this is 100% a moon of this planet because it's not even orbiting in the same direction as the proto-disk was. Oh, but then it gets smacked by another piece of material. But look at that. It's actually, I'm a little shocked by this going counterclockwise. It must have just hit in just the right way. But it got hit and now it's dead. That was interesting though. I really liked seeing that. Beautiful. No, we're getting too close. We're getting too close to the star. Back up. We're getting too close. Yeah, so now we really have 3 planets, as I said. Oh, well, actually, really far out, we have some of these smaller ones. This one, actually, is stable. Like a happy little planet. There's nothing really dramatic going on. It's got liquid water, some ice, solid ground. Like this is literally Earth over here, but over towards the center we still have so much drama. And we get a few little like dwarf planets too, which are doing really well. But these big 3, which are basically gas giants, they just have so much energy that they everything is just vaporized. Everything is vaporized when it touches the surface. I guess it's not a gas giant since it's technically liquid, but they're very large for terrestrial planets. Like they're the size of the star, so. Oh man, and then we have a lot of interesting stuff going on, like the heat causing we actually have the convection currents going on here where the cooling of the materials causing it to fall inwards, and then the hot materials coming out. If there were less collisions, this might actually form a crust at some point, but there's just so much energy in the system. Oh! Whoa, this one has eaten a lot of material. Wait, no, that's the star, isn't it? I just got confused. That is definitely the star. It looked like a planet for a second, especially with these two getting so close together. This is gonna go somewhere, these two. They're definitely close enough together that they're doing a little bit tugging on each other. Oh. Oh no, planet number 3 is about to be assimilated into the star. Oh no, it's gonna only be 2 left. Oh, it's not gonna survive this. It's gonna get ripped to shreds by that gravity. It's actually about to be chucked into the other major planet at huge speed. Oh my god. Oh, this is gonna be dramatic. Oh, it just got thrown. Absolutely yeeted. Yeet! Straight into it. Oh, direct hit! Maybe not completely direct, but enough that it's gonna do some damage. Ooh. That's rough, buddy. Now only 2 planets remain. And actually, the gravitational force from this one is pulling in remains, and I thought it would kind of destroy it, but it looks like it's just going to eat it. It looks like it's actually just going to become a very, very large planet. And the star is in bad shape, man. It's not even a circle anymore. These planets are so large that they're deforming the star. Oh man, it's very dramatic, but still, you know what? We still have Earth over here, which is just kind of chilling. Earth is like, yo, what's up? I'm a planet. And then there's a little tiny one over here too, which is doing really well. It's kind of like Mars, you know, a little bit more ice, a little bit further away, but it's doing well. We got proper planets, but then up in here, man, it's dramatic. Any second, one of these larger planets could eject material and absolutely destroy Earth. It's only surviving by sheer luck right now. It's actually being constantly bombarded with particles, which are heating it up, but not enough to cause any huge problems. But it only takes one. It only takes one large piece of material, like this one actually, which is getting too close for comfort, to cause serious problems for Earth. Oh no, that is a lot of material. This one's gonna miss, but this is a lot of stuff that's about to impact. Hopefully this doesn't shred it. Oh, definitely did something. No, from the other side. Oh no, Earth! 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 Oh no! Oh, just like I said. Oh, the larger planets just absolutely smacked it with material. Oh, Earth, no! Oh. Oh, there's nothing left. That is so sad. That is so sad. Earth just got absolutely yeeted. I just happened to see the moment, too. I thought it would take longer than that. We still have Mars over here, which is alive, and there's a new planet over here. It's just kind of like a oval version of Mars, but the perfectly distanced Earth. It's over. Wow, I'm really sad actually. That was really depressing. I pour one out for Earth. Sorry, Earth. Moment of silence. The star is almost eaten. It's almost eaten everything at this point, really. Oh wait, no, Mars has warmed up a little bit. There's a liquid water. Okay, well, you know what? I'm gonna do my job, and we're gonna. Oh wait. That's not what I wanted. That's not what I wanted. Come back. Okay. I want to put some plant on you. I'm going to give you the gift of life. Ready? Gift of a life. Yes! Life. Do life things. Grow. Prosper. Oh, we're gonna see if that actually goes anywhere, if it all dies. It looks like it's all just freezing. Oh man, I tried so hard. Maybe it'll unfreeze. It got hit by some meteors, but it's okay. The star has now eaten all of the large planets. They're all just one large combobulation. Look at it. Disgusts me. This is communism. This is communism right here. There's only like a few things left surviving. But this planet, I think it's relatively safe. It looks relatively safe. It's so far out that the shenanigans going on in here, I'm not sure it'll reach over here for a long time. So with that, I think we've learned a lot today about survival, planets, and just general enjoyment. So thank you all for watching. We'll do more simulations in Space Simulation Toolkit in the future, and I will see you. That's right, you. Specifically you. The person behind the screen. I see you. I can hear your thoughts right now. They're not very nice. I'll see you next time. Peace out.